quantum computers.
Quantum technology.
What on earth is a quantum computer?
Bits, qubit. Try all the codes at once.
Whichever nation first develops a practical quantum computer will have a tremendous advantage.
Imagine this. One morning, every encrypted message ever sent, your password, your bank info, even your private DMs, all suddenly become readable. Your secrets no longer hidden. Sounds like sci-fi. That is the threat of quantum computing. And it is not as far away as you think. So, what even is quantum computing? To answer this, we first need to understand how regular computers work. Traditional computers, like the ones in your phone or laptop, think in terms of binary. They represent information as ones and zeros, called bits. Everything you see online is built from millions of tiny electrical switches turning on or off. But quantum computers, they use qubits. Qubits are weird. They can either be 1 or 0 or any ratio of both at the same time, thanks to a quantum rule called superposition. Another interesting property is quantum entanglement. When two qubits are entangled, changing one instantly affects the other, even if they are kilometers apart. Einstein literally called this spooky action at a distance. These abilities of superposition and entanglement let quantum computers do something fascinating. They can run multiple calculations at the same time. To imagine this, let's say you're trying to guess the password to a file. A regular computer checks one password at a time, whereas a quantum computer can check millions all at once. It's like the difference between trying every key on a door manually versus using a magic key that tries them all instantly. In fact, a quantum computer with just 300 qubits could perform more calculations than the atoms in the universe. That's the kind of power we are talking about, which can be very dangerous in wrong hands.
The National Security Administration says that a sufficiently large quantum computer, if built, would be capable of undermining all widely deployed public key algorithms.
In a 5 to 10 year time frame, quantum computing will break encryption as we know it today.
Completely new encryption algorithms.
Break encryption.
Quantum-resistant encryption.
A fully functional quantum computer could be built with code-breaking capabilities that could render all forms of online encryption unreliable.
Let me explain. Right now, your online data is safe because of something called encryption. It is math so complex, it would take even the fastest supercomputer thousands of years to break. But in 1994, mathematician Peter Shor created a quantum algorithm that could break this math in seconds. That is, if you had a powerful enough quantum computer. And here's why that's scary. RSA encryption is used in almost all internet security today, and it relies on factoring big numbers. We are talking about thousands of digits long. Classical computers are terrible at factoring such huge numbers. Quantum computers, they are made for it. If someone built a big enough quantum computer, they can crack bank accounts, read government secrets, break into blockchain wallets, and decode every secure communication ever sent, even from the past. As a matter of fact, some hackers and countries are already saving encrypted data today, so that when quantum computers are ready, they can crack it all. It's called the harvest now, decrypt later strategy. Imagine someone reading all your old emails or the secrets of your country from years ago, because the encryption you trusted is now useless. That's not sci-fi. That's real growing threat. So, is it all bad? Not at all. In fact, quantum computing could be revolutionary in ways that help humanity. It can help discover new drugs. By simulating molecules, we can find new medicines faster than ever, or even invent super strong or super efficient materials that would completely change many industries. It would bring an AI boost by exponentially decreasing the time it takes to train machine learning models. It's like giving humanity a calculator on steroids. The possibilities are endless. The thing is, building a quantum computer is not easy. Qubits are fragile. They are sensitive to heat and any kind of noise, even the tiniest vibrations. Right now, we are in the NISQ era. That means we can build small quantum processors, but they are vulnerable to noise, unreliable, and hard to scale. Before we even try to make a universal quantum machine, we need better error correction, cooling systems, and stable qubit tech. Companies like Google, IBM, and startups like IonQ are racing to solve these problems. And the progress is faster than you think. Yet, we can hardly comprehend how important this tech is. Quantum computing is one of the most powerful tools we have ever tried to build. Like fire, AI, or nuclear energy, it can create or destroy, depending on how we use it. Yes, it can break our current internet security, but it can also help us cure diseases, predict disasters, and explore new worlds. The question isn't if quantum computing will change the world, it is how we will choose to shape the change. I am Jay from Growth Cosmos, and if you like this journey through the future of computing, hit that subscribe button to watch more such content. And remember, the tech we build reflects who we are.
Quantum